Formation of differential equations. Learning outcome. At the end of this session, the student should be able to, number 1, find the differential equation from the given general solution, and number 2, verify that the function is a solution of the differential equation. Hi everyone, Assalamualaikum. In this video, we are going to discuss example 1 under formation of differential equations. Find the differential equation given the general solution y equals to c1e to the power of negative x plus c2e to the power of 2x. Right? There are two methods to solve this problem. First, we look at the first method. Right? Right, we are given the general solution y equals to c1e to the power of negative x plus c2e to the power of 2x, right? Since there are two arbitrary constants, the required differential equation must be of order 2. So we need to differentiate exactly 2 times, okay? So from here, we need to find y prime, okay? Then we get this, okay? When we differentiate c1e to the power of negative x, okay, we still have constant c1 in front here, okay. Then we differentiate e to the power of negative x, we get e to the power of negative x. After that, we need to differentiate exponent, which is negative x. So after we differentiate negative x, we get negative 1, okay. That's why we have negative sign here, right? And then to differentiate c2e to the power of 2x, we still have constant c2 in front here, okay. Then we differentiate e to the power of 2x, we get back e to the power of 2x. After that, we need to differentiate exponent 2x. Then we get 2 here, alright. So y prime equals to negative c1e to the power of negative x plus 2 c2e to the power of 2x, right? Then we differentiate y prime, so we get y double prime, right? So when we differentiate negative c1e to the power of negative x here, we still have constant c1 in front here. Then we differentiate e to the power of negative x. So we get back e to the power of negative x, okay? After that, we differentiate exponent negative x. Then we get negative times negative equals to positive, right? And then when we differentiate 2c2e to the power of 2x, we still have constant c2 here in front. Then when we differentiate e to the power of 2x, we get back e to the power of 2x, okay? After that, we need to differentiate exponent 2x. So when we differentiate 2x, we have 2 in front, and then 2 times 2 equals to 4, okay? So y double prime equals to c1e to the power of negative x plus 4c2e to the power of 2x, right? We differentiate 2 times, okay? Because we have 2 constants here, right? Right, then we need to think how to eliminate the arbitrary constant, okay? How to eliminate c1 and c2, right? Right, first, we can name y as equation 1, and then y prime as equation 2, and y double prime as equation 3. Alright? Alright, to eliminate the constant here, we can add equation 1 and 2. Okay, because we have positive c1e to the power of negative x here, and then we have minus c1e to the power of negative x here. We have same term, but one of them is positive and one of them is negative. Right? So we add equation 1 and equation 2. Okay? Right, so from equation 2 here, we put plus and bracket sign. Okay, so from equation 1, on the left hand side, y plus y prime. Okay, so we get on the left hand side y plus y prime, and then c1e to the power of negative x plus negative c1e to the power of negative x, means c1e to the power of negative x minus c1e to the power of negative x. So we get 0. Okay, and then we have c2e to the power of 2x plus positive 2c2e to the power of 2x. So we get 3c2e to the power of 2x. Okay, so when we add equation 1 and equation 2, we can eliminate constant c1. Okay, now we only have constant c2. Right? Right after that, we can name as equation 4. Right? Alright, then we subtract equation 1 and equation 3. Okay, because from equation 1, we have c1e to the power of negative x. From equation 3, we have positive c1e to the power of negative x. So to eliminate constant c1, we can subtract equation 1 and equation 3. Okay, so from equation 3 here, we put minus and bracket sign. So now equation 1 minus equation 3. So from left hand side, y minus y double prime. Okay, so we get this on the left hand side. Okay, and then c1e to the power of negative x minus c1e to the power of negative x. So we can eliminate this term. Okay, and then positive c2e to the power of 2x minus 4c2e to the power of 2x. So we get minus 3c2e to the power of 2x. Okay, then we can name as equation 5. Right? Right after that, we add equation 4 and equation 5, okay, because we want to eliminate constant C2, okay. Alright, so we can put plus sign and then bracket symbol here, okay. So from left hand side, we get y plus y prime, and then plus y minus y prime, y double prime, right? So this is from left hand side in equation 4, and this is from left hand side in equation 5, right? And then equals to 3c2e to x plus negative 3c2e to the power of 2x. So we get 0, right? So now we eliminate both constants, c1 and c2, right? Right after that, we can write y plus y prime plus y minus y double prime equals to 0. Okay, then we simplify, so we get negative y double prime plus y prime plus y, so we get plus 2y equals to 0. Okay, and we can multiplying both sides by negative 1 to make coefficient of y double prime equals to positive. Okay, so after we multiply both sides by negative 1, so we get the differential equation is positive y double prime minus y prime, and then minus 2y, 0 times negative 1 still equals to 0. So this is the differential equation. Right? Now we continue with method 2 to solve this problem. Right? From the given question here, when we compare to the general solution, we have 3 types of general solution. the first type when we have two distinct real root, the second type for repeated root, and the third type for complex root. Okay, when we compare, it is similar to the first one. Okay, our m1 equals to -1 and m2 equals to 2. Okay, or we can write m equals to -1 and m equals to 2, right? Alright, after that, we can move -1 to left-hand side and we move 2 to left-hand side. So we get this, okay? M plus 1 equals to 0, and the other one, we get m minus 2 equals to 0. After that, we multiply this factor. So we get m plus 1 times m minus 1 equals to 0, right? Then we can expand, so we get this, okay? M times m equals to m squared, and then m times -2 equals to -2m, 1 times m equals to positive m, 1 times -2 equals to -2, and then right hand side still equals to 0. Then we can simplify -2m plus m here. So we get m squared minus m minus 2 equals to 0. Okay, then we can write the differential equation is given by y double prime minus y single prime minus 2y equals to 0. Why we get this? Okay, we recall back m1, m squared minus m minus 2 equals to 0 means the characteristic equation. And m2 here, m squared here means y double prime. M to the power of 1 means y prime. And then 2 here means 2 times m to the power of 0. M to the power of 0 equals to 1. So that's why we get 2 here, because 1 times 2 equals to 2. Right? And m to the power of 0 equals to y. Right? So that's why the differential equation is y double prime minus y single prime minus 2y equals to 0. Okay? Coming up next, more examples for formation of differential equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.